Hello my friends and welcome to Origins. It's a great privilege to have you join us today. You know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. And one of the ways we do that is that we interview guests who are creation scientists. And we are honored today to have with us Dr. Jerry Bergman. Dr. Bergman, how good to have you here.
Thank you very much.
Dr. Bergman is one of the most credentialed guests that we have on Origins. He has 2 PhDs and literally a half a dozen master's degrees in various areas of science. But one of your passions is fossils, isn't it?
Oh yeah, I've always loved collecting fossils.
You've been collecting them for a long time. How many do you think you have?
I'm not sure, but I have quite a few.
Quite a few. And how many of them are there in the world today?
There are billions. Fossils, you go to a fossil show and you can buy fossils, nice fossils, for 50 cents. Now, of course, really large ones, rare fossils cost more money, but they're really not that expensive. It's an inexpensive hobby.
Now, fossils are very important because Darwin based a lot of his theory on what he thought would be found, not that he saw, but that he thought would be found in the future in fossils.
Right. He thought the fossil record would either support or refute his idea of evolution.
And so we're here to sort of bring that into account and say, what has the fossil record shown us?
Right. Let me show you some examples.
Would love to have you do that, sir.
Of fossils. The earliest known fern, for example. Now, most of these pictures I'll show you are the earliest examples we have of the various examples of life that we've collected in fossils. And the earliest known ferns have remained the same, we know, for approximately 300 million years. And if you compare a modern fern with a fossil fern, you can see they are identical.
Now, I just have to ask you, do you believe that fossil's 300 million years old?
Well, I'm not going to, the dates I didn't date them, so I don't know. But it's interesting, if you look at the dates, it looks like, assuming they are correct, it looks like a lot of life, most life, has not changed at all in hundreds of millions of years.
So you're going with the dates of the people who have recorded them?
Right. These dates are all of the authorities who have dated them. And I don't want to go into various techniques of dating, but nonetheless, we'll just assume these are correct.
Go with their dates for this show. Thank you.
Yeah, just assume they're correct and go forward. Sumac leaf, good example, and of course you can see the details here very clearly, and you can see the same details in the fossil example. A lot of these are from the Utah Green River Formation.
Okay.
And another example, an elm leaf. Elm is one that I'm very familiar with, and you can see even the veins of the leaf are shown in exquisite detail. And this is true with many of these examples. Sycamore leaf. Very distinct leaf, as you can see here from the fossil record, and you can see by looking at a modern example, very distinct, and again, the vein structure is shown very clearly.
I'm not seeing much difference between the fossil and the living leaf there.
No, I can show these to my grandchild and say, okay, what kind of fossil is that? Where is that from? And they can look at it and say, well, that's a ginkgo leaf. So there's obviously so similar. This is a modern day example, and this is a fossil example, and you can see again, they are, as far as we can tell from the fossils, identical. Grape leaf, very clearly in the fossil record. And there you can see a modern example. Spruce seed, we see these every summer, every spring, and again you can see nice and clear. Ponderosa pine, pine leaf, very distinct. And you can see the pine leaf right here, very distinct in the fossil evaluation. And crinoids, they're invertebrates, they live in shallow water, and their detail you can see, modern crinoids right here, and you can see in the fossil record, when you examine this under a microscope very carefully, you can see the enormous similarity, at least the external morphology is very, very similar to modern day examples. Starfish, this is dated at 490 million years old, and you can compare this, and again what we see is, as far as we can tell, morphologically identical. Herring, there's a lot of examples of fish. Probably 80% of all fossils are of marine creatures. And the herring you can see, compare it with a modern day example, and you can see the position is even the same. And when you evaluate the internal structure, which you can in some of these cases, you can see some of the examples of the bone structure. Again, they are identical. And a garfish, very distinct fish. You can tell that pretty quickly from many other kinds of fish by the snout area here, and again you can see the same thing in the fossil record. This is a good example of the scales, which are very detailed, and they can be compared with the scales on a living garfish, and again we see they are identical. Spider, it's not just plants, but also in this case a spider. It's very detailed here, and you can see the modern example here. A dragonfly, very distinct. In fact, there's a lot of dragonflies in the fossil record, and you can see the wing structure, the general body shape, and so on is identical or close to it as far as we can tell from the fossil record. Ants, wasps, and so on, preserved in amber. Amber is tree sap. A lot of insects have ended up in amber, and therefore we can compare, especially external morphology, with modern day ants, and we can see, in this case, a winged ant is identical.
Now that isn't actually a fossil, that is the actual ant preserved inside the amber.
Ants preserve, and the amber preserves the body tissue fairly well. It's not perfectly preserved, but it's fairly well preserved, and of course insects, they have a lot of chitin, which is preserved fairly well in the fossil record. And a grasshopper, and of course you look at that, you can see, well, that's a grasshopper.
Now there's a point that you're making with all of this, isn't there, sir?
Yeah, the point is very clear, and that is when we look at these fossils and compare it with modern day examples, we see virtually no change whatsoever. Now, in some cases I'll show later there is change, but the change is very minimal. And these are the earliest fossils that I've been able to find in the fossil record, in this case, for example, of a bee. And again, that's identical, as far as we can tell, to modern day bees. Even when we do X-ray advancement of the inside of it, we can see here, this is a spider, and they date at 53 million years old. When we look at the internal structure of the spider, and the next slide shows that better, this is the bottom part, you can see here they literally dissected this with the X-ray machine, so you can see the internal structure of the spider. And again, all the work we've done shows that this 54 million year old dated spider is identical to modern day spiders, even the external and internal parts. And a lobster, doesn't take much education to see that's a lobster, even though that's dated 146 million years, and no change at all. Turtles, this interests me because I've always liked turtles, and we see the earliest turtle in the fossil record is indeed a turtle, and it doesn't take, a 5-year-old could look at that and say that's a turtle. The shell, very distinct, the head, and even some of the leg and tailbone are shown. A crocodile, even a crocodile, we can see, when we look at it, we can see the scales, etc. And again, we have a
now,
crocodile.
That must be a huge fossil, an entire crocodile.
Yeah, some of these fossils are enormous. They have to use earth-moving equipment in order to dig these out and also to move them. And to prevent them from cracking, they cover them with plaster. So the whole unit is moved so it doesn't crack and ruin the fossil. And this is a lizard, 200 million year old lizard, and you can see the detail in here is enormous. And we compare it with a modern day lizard, and that's what we have. Snake, you can see the snake here.
Yes, sir.
And it's identical to, from, again, what we can tell, to a modern day snake. Salamander, same thing. You see all the details here. And a modern day salamander, comparison is very clear. Frog, same thing.
Now, the frog is a 280 million year old frog. You have beside it a modern day frog, and you're telling us that they're absolutely identical.
From what we can tell, and again, we don't have all of the tissue, so we can't do total comparisons.
But you've done so many different species that it seems to me we're building an incredible pattern here.
A very clear pattern we are building, that's true.
And the pattern is that you haven't shown us any evolution. None of these things have evolved. They have stayed identical. According to their numbers with the frog, they've stayed identical for 280 million years. Now, the question you ask is, so where is evolution happening?
That is the problem that evolutionists are aware of, and that is why creationists often point to the fossil record as one of the main evidences of creation.
So now the fossil record is not on the side of the evolutionist, it's on the side of the creationist.
From my study, about 25 years of the fossil record, clearly it supports creation and not evolution.
So the question I guess I want to ask you at this point is, have you ever seen a fossil, and you've looked at thousands of them, and there are billions of them, and I'm sure if there were some that were supporting transition, you would see that. Have you ever seen a fossil that supported the concept of transition from species to species?
When you look carefully at it, it does not support whale evolution. Horse evolution is another example we look at. There are many examples. Human evolution is probably the most well-known, but I've concluded pretty clearly that they may appear if you superficially look at the evidence, but once you examine it in detail, it does not support Darwinian evolution.
Now, Darwin said the fossil record would eventually either prove him right or prove him wrong. Am I quoting him right?
Yep.
We want to see if the fossil record proves Darwin right or wrong. Don't you go away. We'll be right back.
Today's guest on Origins, Dr. Jerry Bergman, is the author of several books, including Slaughter of the Dissidents, Killing the Careers of Darwin Doubters, and Persuaded by the Evidence. For book orders, go to Amazon.com. Dr. Bergman has presented over 100 scientific papers at professional conferences, has over 800 publications, and is a frequent guest on radio and television programs. Dr. Bergman is also a professor at Northwest State College in Ohio, where he teaches biology and chemistry courses. For more information about our guest, you can write to Dr. Jerry Bergman at Northwest State Community College. His email address is jbergman@northweststate.edu.
We are back with Dr. Jerry Bergman, and we're talking about fossils. And we said fossils are very important because Darwin said that the fossil record would either validate or invalidate his theory of how we got here. So, Dr. Bergman, we've looked at a lot of fossils, and it seemed to me that no matter what date they put on them, that the fossil looked identical to the living thing today. Is that right?
Oh, that's true, right.
We want to zero in for a minute on the crocodile. 100 million years old we have supposedly these fossils, and they're virtually identical to a modern day crocodile.
Right.
You said to me off air that the evolutionists often refer to the crocodile as a living fossil. What in the world does that mean?
That's because the earliest example we have of the animal in the fossil record is identical, as far as we can tell, to the animals today. There's no change whatsoever. And by the way, there are many, many, many living fossils. They like to use examples, though, of animals that look like they're old, but indeed are still around today, like the crocodile. The crocodile looks like an ancient reptile, even today.
It's like a dinosaur with short legs or something.
Exactly, right. So it appears to be, by looking at a modern crocodile, it appears to be old. But indeed, while they're modern crocodiles, they're still around today.
So God could have just made them like that. They didn't have to come from anything or becoming something.
It appears that way, and of course we have no transitional forms. And I've done research on crocodile evolution, and basically the first crocodile is a crocodile. They've not been able to even postulate possible transitional forms.
Are there transitional forms, and will we know it if there were?
Well, they theorize there are. What they try to do is they'll take a lot of fossils and they'll line them up and they'll say, well, this looks more primitive, this looks more advanced, this looks even more advanced. So therefore, this must be a transitional form which led to this form. But indeed, that just is an assumption. There's no way of proving. I had a student ask me once, how do you know for sure that an animal is a transitional form? Well, you don't. You can't know, ever. All you can do is say, well, this seems to fit in the fossil record where it should be. It's the correct age according to what we've estimated. Therefore, we assume this must be a transitional form which evolved into something else. But indeed, it could just be an extinct animal, an animal that's not around today.
So what we're doing is taking our theory and then aligning the evidence to support the theory.
Exactly.
Which is it's not the way you really do science, is it?
Well, it shouldn't be, no. You should look clearly at the evidence and extrapolate from the evidence what you can with high levels of confidence.
Now, what did Darwin think we were going to find?
Okay, let me show you what he thought. In fact, in The Origin of Species, this was the only illustration he had in the entire book. And this was what he expected to find. The primitive life forms, and you notice they branch off. And so from this single form here, he expected that we would find a nice tree. And that's why they call this, the fossil record, a tree. And many drawings have been developed from that. And this is one of many. You can see right here the primitive life forms. And we've got, let's see, what else?
So all single form, single cell animal kind of things.
Right.
From the simple to the complex.
Right. And that's what they expected.
Yes.
But indeed, when we do research, and I have hundreds of these diagrams, by the way, but when we do research, what we find is the animal, for chordates, for example, it appears in the fossil record, and then what we see is, in this case, chordates have become far more common, but they're around today, and we can see no evidence of transitional forms. What you expect to find is something like this, which from this animal, not necessarily this one, these are echinoderms, which of course they don't hypothesize chordates evolved directly from echinoderms, but you would expect these to be all connected in the tree-like fashion, which is what you see here.
But what you have is straight lines.
What you have is straight lines. And again, there are hundreds of these examples, and these are actually based on finds in the fossil record.
There's no change, and
Right.
there's no crossover.
Right, we don't see that. And again, here's another example. Now here they're showing you dotted lines where they think, in this case, the crabs evolved from the arthropods over here. So they're drawing you where they think they evolved, but they're honest and they show you this is the theory.
The
And that's
dotted
why
line means theory, not fact.
Right, the dotted line is where they're theorizing how they're connected together.
And there are no solid lines.
Right, and the solid lines are what we find.
But I mean, there's no solid lines leading from one to the other.
Right.
So there's no place where there is a fact that one has become the other.
Where there's a clearly confirmed fact. There are
That's
many
right.
theories, there are many hypotheses, but the transitional forms, there are different theories on whether this is or this isn't, or another animal is, another animal isn't. You always get 4 or 5 hypotheses as to what transitional forms lead to where. Even with humans, there are at least 6 major different theories as to which supposed transitional forms indeed led to humans.
So not only don't the evolutionists agree with the creationists, they don't agree with each other.
Right, there's an enormous amount of disagreement, and that is a problem when I'm doing articles on the fossil record. That is a problem because reviewers look at my article and they say, wait a minute, you've shown what Smith shows and what Jones shows and what Taylor shows. You left out the most important theorist, and that is Gould or somebody else.
Yeah.
You got to add him. You have to add his theory because his theory now is widely accepted, so you have to add his theory to all these other theories that you pointed out.
But isn't the implication then, if you have all these different theories, it's because there's no clear line of facts?
Right. And here's another example, same thing. And these are periphera. And you can see this is the theory down here, the blue lines. And this is fact. What is in dark black is fact. What is in this case blue line is theory. And of course they show you that when they discuss that in the article. And here's an example of a transitional set of forms. They start out here with supposedly the whale ancestor. Here's modern day whales. And here are the ancestors. And when you look at these pictures, it looks like, well, this sounds reasonable. The legs get shorter, smaller. They then are pointed backwards, and then they disappear, and you can see the front part, the skull, etc., becomes more and more crocodile-like, and then more and more whale-like. It looks logical when you look at it here, but when you actually look at the animal itself, this is the first animal in the series, and you can see there's a huge difference size-wise between this guy and the whale. This is the second animal in the series, third animal, fourth animal, fifth animal, and of course here's the whale. When you examine this very carefully, it's pretty convincing to me that indeed all we have is a bunch of extinct animals. In fact, you could take living animals and line this up pretty well to get a transitional set. But of course they don't do that because we're looking at extinct animals because that's part of the definition of transitional. It's one that evolved to something else and therefore it's not around today.
So all this shows is that we had small animals and we had big animals, but it doesn't show that one ever became the other.
No, there's no way you can prove that this guy evolved into this guy. You cannot scientifically prove it. Number one, it's history. Number two, all you can do is say, well, this guy lived a long time ago. This guy didn't live quite as long ago. They look kind of similar, so therefore maybe this guy evolved into this guy. The best example of that is dogs. It's said that if you would look at the fossils of dogs in the fossil record, you could get a nice evolutionary set from the most primitive to the most advanced. Also, they would say that the fossil evidence of dogs, if you indeed found all the fossils of modern day dogs in the fossil record, that we probably would label dogs as 30 or 40 different species. Like the Pekingese, a small dog,
right.
Great Dane, a large dog. They look like very different species because the size differences. And we know that microevolution, if you want to use that term, for dogs occurred because, of course, we did it. We know that all dogs today came from a wolf a long time ago because humans did this work, and therefore we know all dogs are dogs. But in the fossil record, we probably say, well, there are 35 different species here. You have to remember, the bones are very small, 10% often, sometimes 5% of the animal. So the bones are a very small percent of the animal. So it's difficult to extrapolate from bones to the living animal. And therefore, all we have is the bones. You can hypothesize, well, gee, this must be the ancestor of whales. Whales is interesting because they theorize that fish evolved into reptiles, and then amphibians and also mammals, and then one of these mammals evolved back into a fish-like animal. So it evolved from the water to the land, and from the land back to the water.
That is interesting. It took a good imagination to come up with that theory, I guess, but you had to explain the whale being there somehow.
Now, we do find some evidence of microevolution. In this example of trilobites, and we have a number of fossils. In fact, trilobites, we have an enormous number of fossils. So we're able to measure here averages of different structures, and you can see they do change. But this is an important point because they're not evolving anywhere. They're changing this direction, back, then this direction, then back, then this direction, then a little change here, and then this direction. So there is some change, but you're not seeing trilobites evolving into anything else.
It's just a different kind of trilobite.
No, yeah, different number of certain traits. The traits change in size and number. And we can see the same thing here with this example, with this example, this example, and this example.
All right.
And another example here is, these are planktonic radiolarians, and we can see these are microns. Now, it looks like there's a lot of evolution back and forth, but we're talking about changes in a structure here in microns, which is a very, very small change. And again, we see the back and forth. And we have enough fossils where we can evaluate the change in the fossil record, and what we see is basically we start out with this type of animal, and we end up with the same type of animal.
Come down here and join me and talk to me for a minute, because I want to ask you a crucial question. Would Darwin today, if he were an honest man, be a Darwinist?
I think, no, he would not. He realized in his day that the fossil record was a major problem in his theory. But he felt, as we kept digging more and more fossils, and of course we just begun looking for fossils in his day. As fossils accumulate, he was confident that we would indeed have a very impressive fossil record to support his theory. Keep in mind, there may be 1 million different species, so how many transitional forms do we need? We need billions of transitional forms.
Wow.
And yet, how many have we found which are even claimed to be transitional forms? Very, very few. There are some they claim to be, but there are very, very few compared to all the animals that we have.
What's the point from the Time magazine cover here?
That's an interesting cover because when you keep up in this area, you'll notice that covers of various journals and magazines point out changes in our interpretation of the fossil record. We have revolutions. We now have to reinterpret the whole fossil record. And in this case, they're pointing out the evolution's Big Bang was the fact that what we find in the fossil record is over and over abrupt appearance. Animals are not in the fossil record at all until a certain point. They appear, and then they are very, very common, like trilobites, and then they disappear, and that's it. They appear, and they're still around today, or they appear, and they disappear. That is what the fossil record shows us.
As an expert in the whole area of fossils, do you see anything in the fossil record that supports the theory of evolution or Darwinian evolution?
No, I don't. We see plenty of minor changes. In fact, we see some pretty major changes. But we don't see at all what Darwin expected. We don't see from the goo to you by way of the zoo. Just don't see that at all.
You know, my friends, it's really important that you understand what's really out there, what science has really shown us, as opposed to just theory. The theory of transitional forms is rampant in our schools. It is absent in our fossil record. And I'm so thankful that we have men like Dr. Bergman who have taken their whole life and given it to really looking objectively at the evidence. And after you look at the evidence and you look at God's Word, you can believe the Word of God, because the fossil record has nothing that disproves God's record. You know, my friends, I want you to remember until we're here again that it's God's view that He created you. And that should be your worldview too. Hold on to the truth, my friend. Don't be duped by theory that doesn't have any evidence to support it. We hope you'll continue to join us here on Origins as we give you the truth of creation validated by the evidence of science. Join us again next time here on Origins.
Thank you for watching this edition of Origins. To get a copy of the information presented today, you can download a PDF file of program number 1107 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 1107, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.